but there is a return statement here. But do we always execute the return statement whenever we invoke the subroutine S1 here? The answer is no. Okay. So if you look at line 7 is printing the result of invoking S1 using 2 to specify n, right? Doesn't seem to be any problem here because 2 specifies n. When we get into the subroutine, this is 2. 2 is less than 3. We return a value of 2. It will just print a value of 2 as the print statement. Not a problem. Okay. We look at line 8. Line 8 is invoking S1 using 5 as the argument to parameter n. We go into the subroutine. By the time we get to line 3, we'll say 5 is less than 3 is false. Okay? That is false. We are not going to execute line 4. There's no else. We'll go all the way to n define sub. But hold on a second here. That means this question mark here in the return info cell will remain as a question mark by the time we get back to line 8. Right? And that's exactly what happens. In other words, if you write this program in C or C++, the value that it will print on line 8 is undetermined. In other words, it will print something. There will be a value, there will be an integer printed, but you just have no idea of what it will print. Okay? Do we have any questions about the concept of a missing return statement? It is bad. Okay? It is very, very bad to have a subroutine that is expected to return a value, but in certain paths of execution, it does not happen. Okay? Because it will still return something, quote unquote return something, it's just that that question mark will never get resolved. So by the time you utilize the question mark, you have no idea what that value is going to be. Okay? Any questions about this? No questions? Now, I do have to add this part here. Most compilers can catch this type of problem of missing returns. In other words, a compiler can analyze the source code and it will say, oh, you know what, at certain points of this program, there may be a return that is missing, even when it is tricky like this. Now, if I don't have a single return statement of the entire subroutine, yes, it's obvious, and most compilers can catch that. But in this case, I do have a return statement. It is just because of the structure of the program that I may not end up executing that statement. A good compiler would actually catch that as well and say, you know what, sometimes you don't actually get to execute the return statement, and it is a problem. Okay. Let's go ahead and see what it actually does, because we have 3 minutes left, not enough time to really start a new topic, but I can go ahead and give you an example and just show you what happens when I write programs like this. Okay, so this is written as a C program. And I will go ahead and write a subroutine that is supposed to return an integer. It will take an integer n. The syntax obviously is quite different from the pseudocode. In this case, n is my bi-val parameter n. And I will use the same code. If n is less than 3, and we don't use a then, that's it. So here we'll specify we return a value of 2, just like with our pseudocode. We have our main subroutine. And we'll go ahead and print. Okay, this is really convoluted because it's C, but all it does is to print the value of invoking f with a parameter of 2, argument of 2, and then it will print again with a parameter of 5, and main itself also needs to return 0. First of all, we want to see if the compiler can catch this problem. Bad return.c. And that's a syntax error. It's line 7. Need a semicolon here. That's the sort of stuff that you guys have to deal with next semester. Oh, it's missing a semicolon. Oh, it's missing a closed curly brace. Oh, it's missing a closed parenthesis. Oh, it has one extra open parenthesis. That is bad. Okay.
Been there, done that.
Okay, so we'll go ahead and compile the program. And the program compiled without any warning. And that's because I did not tell the compiler to be naggy. Okay, so there are ways you can tell a compiler to be naggy. One of the things that you will learn to do, and you should do, is to specify the dash wall option. Dash wall represents dash warn all. If it finds any problem, tell you about it. And it tells you that. It tells you on line 8 of the program, control reaches end of non-void function, which is a very cryptic way to say that the subroutine is supposed to return something, and sometimes it can get to the end of the subroutine without actually returning anything. So we'll go ahead and just give it this here. So I will say else, say return 100. Okay, that should fix the problem. Because if n is not less than 3, it will go here, and in either case, it will return something. We'll see if the compiler is smart enough and let me go this time. And it does. So the compiler is actually quite smart. It will basically look at all the branches and see if there's at least one return for each termination path or terminating path of the execution of the code. If there's at least one return in the path, then it's going to be okay. Next, we'll also take a look at the other problem that we were talking about of this. Okay? Right? We'll go ahead and compile the program the first time without any warning. And it says, yeah, it's okay, not a problem. And then we'll turn on all the warnings. And it still does not complain. That is bad. Okay, I think I have to turn on something else. I think I have to turn on the optimization thing. It still does not give me a warning. That is not good. There are other tools other than the compiler that can analyze your code and nag you to no end. So look for those tools. One of those tools is called lint, L-I-N-T. And it will do a very good job complaining and criticizing your programming style and everything else. Okay, it's a good thing. Okay, it is a good thing to get nagged and complained so that you can fix the program before you even run it. Okay, so that's the end of today's class. I hope you guys are getting a better idea of all the returning mechanisms and whatnot.
Okay, so after today's little thing, I kind of see what I did wrong with my